What? Good morning. Thank you all for joining us today. I hope you're all having a wonderful evening, afternoon, or morning, wherever you're located. Um, so, Anna, would you mind changing the screen?
Pardon?
Would you mind just
This
flicking over
slide?
to the next slide? Yeah,
Yes, sure. Yeah, we go
wonderful.
together.
Thank you. So if everyone could just turn off the time, no, not turn off the time, sorry, turn off the notifications and sounds, that would be very useful for yourself. It would just mean that you can pay more attention, which is ideal. And then also if you could utilize the Q&A section, it's just in the top taskbar, or bottom taskbar, depending where your taskbar is for Teams. Alternatively, if it's not showing up there, there's a three dot and then more section. So if you just click on that, the Q&A will be in there. So then you can ask Dr. Anna any questions that you have. Just switch. Actually, we'll just give
Yeah.
some common questions and frequently asked questions in regards to the copy of the slides, and then the certificate of attendance. So this will be shared with you at the end. This link for the certificate of attendance will be shared at the end, and then I believe it's within 3 business days, the certificate will be sent to you, and then so will the copy of the slides. Wonderful. So about the Engineering College of Technology and the Engineering Institute of Technology. We specialize in engineering and technology, which is fantastic. We offer personalized student support through learning support officers, which is amazing. And then, yeah, we're just really focused on sticking and staying with what the industry needs as well, which is fantastic. We are globally recognized and industry focused with leading experts as well. Awesome. The disclaimer, so the courses and qualifications mentioned in this presentation are offered by separate legal entities operating in different jurisdictions, one in Australia, one in the United Kingdom. Each entity is subject to its own local regulatory requirements and accreditation standards. Prospective students should refer to the relevant institution's official website for accurate, up-to-date information specific to their location, including course availability, fees, regulatory status, and enrollment conditions. And there'll be some links there for you to use once you get those slides, which is fantastic. I'll switch to the next one. Thank you. So today will be a webinar based around the trends in concrete repair, material and methods delivered by our wonderful Dr. Anna. I'll just bring you on screen. I'll take myself off.
Okay. So thank you. Thank you, Jasmine. Do you want me to continue with the next slides, or I can take over from here? Is that fine?
Yeah.
So first of all, thank you everyone for the opportunity to meet you today during this webinar, this technical webinar. As Jasmine mentioned, our main goal at EIT is just to offer the topic is according to the industry trends. So that's why this is one of my favorite topics, is about concrete, but here we're going to talk more about concrete repair. We're going to highlight some points about the material side of things and the methods. So I will just briefly introduce myself. I'm a civil engineer with more than 20 years in academia and doing research. I currently am senior lecturer at EIT, and I used to teach bachelor's degree students, master's students, And now we at EIT, we offer our doctorate program. So I also supervise the doctorate students. So this is a bit of me. And now we can start. If you have any doubts, any questions, you can use the Q&A session. At the end, we can give you some opportunities to just ask the main points you are concerned or you want to know a bit more. Just keep in mind we have some limitations in terms of time. I tried to summarize main important points about repairs of concrete. Today we're going to start with some just very brief review about concrete composition, durability aspects, defects, testing. We're going to dedicate some time here in order to discuss more about concrete cracks. I think it's our favorite topic, subtopic. And at the end, some points about concrete protection and some repair techniques. Okay, so let's start one by one here. So the main point today is to understand deterioration in concrete, because you have existing structures and sometimes new constructions in a very short period of time showing significant defects and deterioration. Just to highlight, and when we talk about concrete here, concrete is a composite material. At the end of the day, we need to understand the characteristics of each component. As you can, now I 100% believe that you're totally familiar with this material, because concrete is one of the most used construction material around the globe. It's a combination of cementitious materials, normally combined nowadays in different countries, cement Portland plus any type of pozzolanic materials such as fly ash or silica film, it depends on countries. We also have fine aggregates. We cannot forget air is part of our composite, water, and coarse aggregates. Usually, modern concrete, we have incorporation of chemicals, right? Chemicals admixtures and mineral admixtures. So when you have all these combined, we can identify a variety of characteristics of the final product. And the final product is concrete. So just to illustrate this initial part. So when we think about existing structures, we need to understand a bit more in terms of the durability aspects. When you talk about durability, straight away, you need to think about concrete quality. It also relates to the design, concrete design, the service life of this material over time. And we just ask ourselves why some situations we have a severe deterioration of concrete, which in future will require more investments in terms of repair or strengthening and maintenance. So we have some simple factors that you can consider here. It can start on the design stage or in terms of very poor, bad specifications and workmanship. Unfortunately, construction industry, we still need lots of training for our laborers, right? I think not, I'm based in Australia, but I'm from South America. We can identify this type of issue everywhere. When you think about quality of concrete, we have a combination of characteristics, right, that we need to keep in mind. Permeability, strength, here is strength, sorry about the typo. We have the concrete components, as I mentioned, depends on the type of cementitious materials. More and more we are working with a combination of cement Portland plus pozzolanic materials and selection of aggregates. So we need to understand these are the fundamentals of durability. A bit more here in terms of concrete permeability. Why we need to understand this? Because this will provide us the fundamentals we need in order to understand what happens in future in relation to the simple defect as cracks that you're going to be talking later on. So permeability in concrete, it depends on porosity of this material, the pore size distributions, and continuity of those pores. It's how, for example, if you have your structural element in front of the sea, it's about the ingress of chlorides. Or another factor that deteriorates concrete is the carbon dioxide, carbonation of concrete. So my opinion is we need to do our best as civil structural engineers, or if you are working with concrete technology, in order to ensure that you produce high quality material. Because then you can avoid, or at least can postpone this type of defects to occur. So in my opinion, it's much better to dedicate some effort and time in order to produce high quality concrete rather than do some repairs in future. It's about prevention. So if you understand the concepts in terms how to produce a high quality concrete, you can minimize the defects to happen in future. So here you have, I just highlighted here some points for you in order to better understand the factors affecting concrete permeability. Some of them very well known from all of us, the water cement ratio, but during in situ, we have some situations that we don't have effective compaction. If you don't have effective compaction in situ, definitely it can cause some porosity. And if you have a porous concrete, you know much better than me that the final result is lower strength, and then you can imagine in terms of deterioration how it can progress in a fast pace. And the curing process. So this is all combined. Always keep in mind, we are talking about composite materials. When we talk about deteriorations in concrete, we need to understand concrete it depends on the environment, the exposure of concrete in different environments. Here is just some illustrations about chemical attacks, very common. Depends on if you have groundwater, and depends on the location of your structural element. So sulfate attacks, what happens with concrete to end up in this very, very bad condition here? It's about in terms of the chemical mechanism, you can have the dissolution of the sulfates that penetrates in concrete, and there are severe consequences, as you can see here. I just selected this photo just to highlight how severe it can be. Thinking about the structural point of view, aesthetics is something that concerns us, but mainly structural integrity. So that's why consequences of this type of chemical attacks, we can see expansion, crackings, and can result in the collapse of structure. So how we can minimize this to happen? Control measures here in order to avoid this to happen. Denser concrete, when it's about our concrete mix design, when you have a proper mixed design, we can produce a denser concrete, reduce permeability. We can just try to mitigate the ingress of sulfates and minimize the amount of calcium, tricalcium aluminate here. So this is some points that we can highlight about sulfate attacks. Another problem, why we talk here about shrinkage, because in future, when you think about the repair of concrete, we need to think about why cracks occurs in concrete. And shrinkage is one of the factors as well, one of the main challenges we face when you are working with concrete, because it starts from the fresh concrete. As you can see here, we are talking about plastic settlement shrinkage. So that's why sometimes if you don't observe the issues when concrete is in a fresh condition, in 3 days, 4 days, 7 days, you can see some cracks in your concrete, especially if you are working with slabs and pavements. Probably majority of you just face it is in your personal, professional, in your workplace, in your professional life. So when it's about any type of characteristics of concrete that can end up on cracks or other types of defects, we normally have this procedure to follow. We need to understand, I don't need to go one by one here. You're going to have these slides for you later on, but we have kind of a algorithm to follow. We need to understand why this uh, happens, when, where is the cracks, depends on the patterns of cracks based on the plastic shrinkage of concrete, sizes of cracks, because and as you can see, if in a very, very early stage, I think within 24 hours, more or less, or 48 hours, you can have some micro cracks and cracks, but if you ensure a proper curing condition over time, some cracks can heal. You can avoid this situation to get worse in future if you get the proper measures. So, and the control, right? Control consequence, it's about decreasing durability, decreasing the integrity of the structural element surface. And when it starts at the surface of your structural element, you have an open channel, I can say, in terms of the ingress of chemicals, moisture, and reinforced concrete. This is another point we're going to talk later on. It's about corrosion. So this is about shrinkage. Here I just illustrate. I don't go in details one by one, but when you talk about shrinkage, we need to understand the different types of shrinkage in concrete. It's from the plastic shrinkage when it was in a fresh concrete, but here you also have a dry shrinkage, very easy for us to visualize. Concrete just shrink over time, and you can imagine why cracks happen, because the concrete strength is not at the level in relation to the internal stress applied in concrete. So that's why you have the cracks formation and propagation. Cause, it's a cause of, if you have a keyword here, dry, is about loss of moisture over time, and parameters that we can observe in order to prevent this. Depends on the geometry of your structural element. We also need to think about the curing condition. It's clear, and so many researchers just proved this. And in real life, you can also get this evidence. When you have a longer moisture curing, you can observe the mitigation of drying shrinkage. So on top of shrinkage, we have on the plastic and drying. We need to be very careful. Depends on location of your project in terms of the temperature. Deformations in concrete. Deformations, when we talk about deformations, we just need to think about shrinkage, and creep. It's another example of deformation. But here it's still in terms of the temperature change. So one of the examples that I just selected to share with you is when we have a massive concrete. Let's imagine a huge dam, concrete dam. You can imagine if there's a significant gradient in terms of temperature, you're gonna observe cracks formations in a very short period of time. So high temperature or in a fiery condition, no doubt you have the reduction of strength, because you can concrete have some limits in terms in resistance, fire resistance. So we have the decomposition of hydration phase. So that's why we can identify gradually the deterioration of concrete, and it can go to the level of aggregate, and stress concentrations results in cracks. Okay, so this is about shrinkage and occurring from plastic shrinkage, dry shrinkage, and depends on the temperature, exposure to temperature. So here is more to show you how it can look like shrinkage. Cracks can occur, depends on the improper curing, such as summarize the points why we covered shrinkage, because we need to understand this type of defects occur considering improper curing, or it can be problems in the joints of your project, your structural design, and steel reinforcement, poor steel reinforcement, because, you know, cracks are results of a lower tensile strength of concrete. So that's why we need to understand the fundamentals of concrete. There are so many other durability issues that I can't keep talking for more than 5 hours, but today you have 50 minutes, more or less. So we have acid attack, alkali aggregate reaction. Can you just give me some idea if you are familiar with those other types of durability? Just a thumbs up if you are familiar with those. Alkali aggregate reaction, corrosion. I think you're going to have lots of thumbs up. Everybody knows about corrosion. Carbonation, when you have ingress of carbon dioxide in your concrete structures. Chlorides, freeze and thaw and cycles, and biological attacks as well. So here is another illustration, just for you to have an idea about efflorescence. It's a salt deposit. I think all of us, when we just identify this type of, it can be, I can say, aesthetic issue, but not only about this. You can see that's visually unpleasant, but this is a red flag. Straight away, you can identify something must be done here, right? Otherwise, it can progress. If it progress, if reinforced concrete, the corrosion will be starting in a very short period of time, or if already started. And cracks formation and propagation. We're gonna talk a lot about formations, cracks formations and propagation. We're gonna get there on the materials and repair techniques. Are you gonna answer your questions as soon as we get to the end, okay? Just to not compromise the time. So in terms of structural deficiency here, inadequacy in terms of construction flows, we have the majority of the stress can caused by, that's why I mentioned to you, it's a combination of factors, not the only one. It's about the lack of sometimes skilled laborers and the lack of quality control in our materials. It's about construction practice, majority of the stress on beams. So it can be also not using the proper concrete mix according to the application or to the level of the loads applied can also cause some damage. And finishing the tailor, as you can see, deficiency in the structural elements can be caused by different factors, but majority of time they are all combined. Very hard to identify only one factor affecting the structural deficiency. So we have, as you all know, in order to ensure what's happening with the concrete in situ, we have some types of tests that you can conduct. For today, I just mentioned this one in order to identify the level of strength in situ, but we have ultrasound, you have some modern techniques that we can get inputs from the characteristics of concrete in situ. Here is about the rebound test, just to illustrate that we can obtain the characteristics of concrete in situ using some different types of non-destructive tests. We need this during the inspection phase in order to understand the level of repair that you may need. As you asked how to fix it, the fluorescence, sometimes it depends on, it's more about the aesthetics, but then if you dig down and understand the level of the strength of the concrete in situ, it can become the need not only for the repair, but for the strengthening as well. And the other points is you can see, just to illustrate more about, we need the non-destructive test in other techniques to analyze what's happening with the structural element, and then we can prescribe. It's like when you go to your doctor. First of all, you need to understand what's happening with you, and then the doctor can prescribe the treatment, right? So we cannot jump to the treatment if you don't know exactly the cause, and that's why this is the investigation phase. So it depends on the system can present some discontinuities, and then we can have the cracks. Yes, now this is how you can understand the reasons for crack. As I mentioned, if you understand the cause, then we can prescribe, I can say, the solution. So we have a variety of situations that we can identify cracks formation and propagation. Here, for example, we have improper subgrade preparation or earth compaction, settlement, inadequate or improper curing. This is very, very common, right? We we have standards to follow. We need to ensure why curing is important to avoid cracks formation. As I mentioned at the very beginning, you all know we have our concrete mix. Concrete is delivered in situ, and over time you can see the strength development gain. When you have the critical 24 hours, 48, 7 days, if you ensure the moisture in your concrete, you can ensure a proper strength development gain. When you do this 7 days, 10 days of a proper curing process, the main point is to minimize the probability to observe cracks in future, right, in your concrete. If there's no proper curing, this is very simple control that we can just pay more attention when you are a site engineer, for example. Incorrect finishing, excessive water. Why excessive water? Because we also covered before, we have the drying shrinkage as another cause of cracks formation. But now let's look at the construction practice. What can be done in order to minimize the cracks formation here, based on the construction practice? When you have the workability of concrete, it's one of the, it's very common if you don't control the amount of water in your mixed design, because majority of us is when you are site engineer, you want your laborers to work easily with concrete. That's why workability is critical. But if you have at the same time, if you don't balance this, you observe the increase of the amount of water to make concrete easier to mix. So this will lead on the reduce of strength and increase the settlement of concrete. Plastic shrinkage, dry shrinkage, just observe they all occurs at the same time, right? Not separately. So the other point here, when you can see the way we mentioned about the gradients in temperature, is depends on your location. For example, here in Perth, it's summertime. During the day, we go for 40 Celsius, and during the night, 15. So those gradients of you can also affect the quality of our material in terms of the temperature, especially when if you had doing the concrete during the severe conditions, right? You need to have some alternatives in order to ensure that you don't have a significant variation in temperature. And it also goes to the curing process. Sometimes the curing starts and stops and starts and stops. So you can see the water evaporates when you have this lack of curing. If the curing is not a continuous process, If you just so 1 hour you have the concrete is moistured, the other hour the concrete is exposed to sun, so it's gonna lead on cracks, and then we all need to figure out how to fix it. So it's better to ensure a proper procedure during the construction stage. So cracks in concrete, we mentioned at the very beginning about the concrete as a composite material. More and more we know that when you have cement Portland plus water, it's a chemical reaction, it's an exothermical reaction. That's why when you replace part of cement Portland by fly ash, for example, you can have the mitigation and you can observe some reduction in terms of the heat of hydration. All this can reduce probability of cracks in your concrete. Also here, during the hydration, when you just have a long when you think about long-term characteristics in terms of strength and durability of concrete, everything that you pay attention here at the very beginning will ensure long service life of your structural element. Another point that can lead to cracks is about formwork support, consolidations, placing in the joints in high stress areas. So sometimes the problem starts in the design, the structural design. So if you don't have some proper reinforcement in critical areas of stress, you all know that you're going to end up in cracks formation in future because of the excessive stress. And you know, especially when you are working with reinforced concrete, the detailing in our structural design majority of the time is to accommodate both, right? It's about ensure the structural element will resist against the flexural stress, against the tensile stress, but also minimize the cracks formation and propagation. It's not only about stress, it's also about cracks, formations, and propagation. That's why here I just highlight, I mentioned before, but here you can see the summary in terms of the errors in design and detailing, especially when you have corners, or even though when you have the precast elements, also need to observe this type of cause that can lead up on cracks. In the contraction joints, joints are critical. If our material needs some joints, but concrete will deform over time, right? We know this. And if you don't have a proper joint, what's going to happen with the concrete? There will be some stress generated there. If there's some stress, internal stress, these internals will lead to cracks. So all those are important points to keep in mind. Here you have some other points in terms of, for example, the last one. Let's just get this one. If you have slabs or walls and they are restrained, if they are restrained, even if they are pre-stressed, they can develop tensile stress. This is what I'm trying to highlight here. Let me just make a little bit bigger. Tensile stress, this is the cause of cracks. And why we need to know this? Because we need to know how to fix it. In order to fix it, we need to ensure the concrete will recover the capacity in order to resist against tensile stress. This is the weakest concrete in terms of its properties. Concrete, it's not the best material to resist against tensile stress, right? You all know this. So here you have also differential movements. Now, very small cracks can occur. This is another point we need to keep in mind. And yeah, sometimes differential movement in settlement, the structure cannot redistribute loads. If the structural element you're not capable to redistribute loads, it ends up on failures. So another cause. And I now we're going to talk more about the repair methods until the end. Methods, materials, but now you understand, you understood the cause. Now we can have a better understanding in terms of how we can treat it or try to fix it as much as possible. The system, we have some fundamentals. We just selected 7 fundamental steps when it's about the repair methods. Identify the damage, the step number 1, otherwise how we can prescribe some solutions and treatments. Severity of damage, as we could see, can be a simple with fluorescence. You can clean up and can have another layer of concrete or mortar or grout, but depends on the severity, it can go to the structural level. So necessity of repairs by doing some in situ inspection, and then we can, with all these combined, we can do some analysis and identify a suitable technique and materials in order to repair, or if it's the case, to enhance the strength of the structural element. You can have the strengthening as well techniques, and start with some strategy and completely the cure of repair. Okay, when you are working with another concrete, a new concrete, you need to ensure a proper curing condition. So in terms of the repair methods, these are one of the most traditional ones when you have the epox injections. So it depends on countries and locations. You have a variety of materials available in all the different epochs in terms of what can be used in order to seal the cracks, right? Injection, the epoxy injection is one of the most traditional ones. So this gonna seal the cracks on the exposed the surface. So epoxy injections is one of the alternatives. So the other alternative is when you have the routine and sealing. When this is more and much simpler, when you the cracks here, you can see into these diagrams. You have the concrete in the dormant, and sometimes they can be resealed. So we have here some appropriate materials, some resins or some grouts that you can use. So normally you have the widening along the exposed and usually have the V shape in order to ensure it's gonna be proper filled and sealed. So other techniques are more modern techniques that I selected to share with you, but I will share this video only with you later on because it's not a very short video. But I think in terms of the trends and modern technology, in order to seal some to when you are working, especially with pre-stressed concrete in some beams, this is a very cutting edge technique here, because here we those researchers, they work it with ultra high performance, and here is working with a fiber reinforced concrete. So this is one of the modern techniques that you can use. Is now sometimes, as you know, the modern techniques, they still need time to come to life and to be applied in the industry. But I think it's very important just to highlight types of new materials coming in order to ensure that it can, in this case, when you have this type of material, ultra high performance fiber reinforced concrete, it can fix in a level of very small cracks and post cracking. So this type of material can ensure both the mechanical properties and durability in order to exceed the traditional concrete characteristics. So it definitely, when you have what I want to also highlight later on, you have an opportunity to watch this video. It's about the understand the effect of fibers, how fibers can ensure longer term. When you have the fiber reinforced concrete, you mitigate a lot the cracks formation, small cracks, and to stop cracks propagations as well. So it comes to a cost, no doubt. So, but I think it's important, especially for all of us, to keep up to date with the current trends. That's why I feel important you're gonna look at this. So when you have this type of materials here, ultra high performance fiber reinforced concrete is about high level of compressive strength, flexural strength, tensile strength, and so on. So we're gonna leave this for you. Other options I selected to share with you in terms of repair methods is stitching and cracks. So this is one of the reliable ways to fix concrete. It's like a stitch, as you can see here. If you have faced this before, if you had some experience in your workplace, or if you just had the opportunity to visualize this type of service, please just let me know, or you can say yes or no in your chat box. And after, yeah, this is something that can be done in terms of methods. And in terms of the repair techniques, I just illustrated some of them, but now you can see the list of repair techniques. It can go to the level of voids in concrete when you have a porous concrete. Majority of times about injection of resin, but other procedures or other techniques such as cut and repair. When you have cracks from the top of the reinforcement here, majority of time it's a question of the recompact the concrete when it's still plastic. As you can see, some alternatives you can do it when it's still in a fresh condition. Concrete is in a fresh condition. And lack of cover, we can apply lack of cover. Why it's a problem? Lack of cover of to reinforcement. Can you put in the chat box why it is a problem? Lack of cover to reinforcement. The consequence. What is the consequence? Why you need to apply a protective coat? Consequence of lack of cover. Just think about this. Yeah, 100%. Yeah, really nice. This is another problem, you can see here. What's the main issue about a lack of cover? So as I can see, there is no miracle here. If you start from when you concrete is delivered in situ, if everything is done properly, you can mitigate all this. Definitely repair will be there, but you can postpone this. So corrosion, this is another critical part here. Corrosion, as you can see here, it's not only about the aesthetics, you all know this, it's about deterioration of your structural element and structural integrity and the cost of corrosion. So engineers are trying to work with the new coatings materials, just in order to mitigate this situation to happen. Because when it's a very severe environment, you can imagine the difficulties to inhibit corrosion and the amount of money for this. So corrosion is about one of the main factors about deterioration in our concrete. So yeah, here depends on the severe environment. It still is a thermodynamically unstable, and it's about the corrosion mechanism. And why we are concerned with corrosion? Because it ends up on cracks, right? And the cracks, even though starting as small cracks, if it progress, compromise structural integrity. And if you compromise structural integrity, we don't want the collapse of our buildings or bridges. This is the main point for us. You have some illustrations in terms of corrosion mechanisms. So you're going to have these for you to understand in details later on. But you all know you have the concrete. If you have lower permeability, lower porosity concrete, it's a protective layer of your steel. But when it deteriorates, when you have the oxygen, water ingress, or chlorides, corrosion process starts. So this is one of the points and the stages of corrosion, some illustrations for you. And prevention, assess strength reduction. Yes, yes, in situ, it's possible to do this. We can, yeah, that's why the in situ tests, we also can identify the level of corrosion. It's about the resistivity of concrete. We can have this type of correlation, strength of concrete and corrosion. But as you know me, you will really understand why I highlight prevention, because you avoid excessive cost in future. So prevention of concrete corrosion, you can see here, the quality depends on sometimes the contaminants in your materials. I'm not sure if you heard about it, but sometimes building collapse in the cities when you have coastal areas, because sometimes the sand, simple. We cannot imagine that it happens, but if the materials is you can use a sand with lots of salt. What's going to happen with your reinforced concrete? So clear cover, epoxy coating depends on uh, the type of project, the complexity of project, the severity of the environment, your structural element to be exposed. You can go to this level of epoxy coating in order to reduce or mitigate as much as possible corrosion process. It's about also have some techniques such as cathodic protection. You've probably heard about this. Cathodic protection, anodic protection. We have the paintings, right? In order to ensure, for example, we have the most common example is about the zinc. When you have zinc, when you have the painting, the zinc will corrode and you protect steel. So we have those techniques. Proper workmanship, sometimes simple control techniques, ensuring proper compaction in the mixed design, deteriorations that can happen based on the excessive amount of water. We have here bleeding or segregation. All these can be controlled, and it's a very simple type of prevention of concrete corrosion. And yeah, here is some techniques for testing. But we have the health cell potential. This is what I was trying to explain before when you asked about the correlation between corrosion and strength. So there are some techniques in situ that you can understand the level of corrosion. And you can have a contour map of the corrosion. We can map everything in situ, and without the need in order to start drilling holes and causing some little damage in your structural element. Here we also have other examples for you to evaluate corrosion in terms of ultrasonic testing, eddy current testing, infrared thermography. As I told you, non-destructive tests now. You have so many new equipment coming to industry, and in order to identify all those defects in situ. Protection, in terms of protection, concrete with reinforced concrete is the composite material, concrete's the ones that you can protect the rebars. There's nothing very difficult in this sense to understand, but other techniques here in terms of protection is with the hydrophobic impregnations. So why we need this? In order to ensure that we don't absorb the significant amount of water from the humidity in order to stop the ingress of contaminants. And the common type of contaminants, it's about the chlorides, depends on the environment. So protecting can prevent then the naturally concrete protects the steel bars. Also, this type of protection can be achieved in different ways. When by coating, as we mentioned before, we can also, another technique is about the application of corrosion inhibitors. and cathodic protection. So all those are good alternatives. Though, let's have a look one by one. Here we have the protective coating. Protective coating, as we can imagine here, it is pretty much to ensure that prevent water to ingress and other contaminants. So it also have some components here when these protective coatings are based on solvents, resin, and pigments. So those are the main components. When you talk about coatings, in terms we have the vehicle. Vehicles are the solvents or resins, and the pigments can be some color pigments and inerts and reinforced. So here I'm gonna leave with you this type of tables, and you have in terms of protective coating, you have some actions, the nature of action, conditions and type of the destructive threat, and the deterioration of coating. Okay, so here let's have an example in terms if you have the nature of external chemical, the conditions of the destructive can be absorption or diffusion. So chemical destruction, it can end up on degradation. So that's why the need of protective coatings in different conditions. And sealing concrete. Sealing concrete, as you can see, this is the protective covering that can use a sealer like acrylic or epox in order to ensure that you minimize or mitigate the amount of uh, water ingress or the contaminants. So these penetration sealers, they have a saline or Celonex, this one, in a porous surface, it can become and it can build up here. It can and it becomes a protective layer. So there are some different options here. This is one of them in order to seal concrete. So specific applications is you can, in terms of sealers, I'm just going to provide some examples here in terms of you have the resin based like acrylic here and styrene acrylic. So as I mentioned to you, you just need to understand the techniques, but the materials available depends on the suppliers in your specific country, in your specific location. I encourage you, step number one, to understand the cause, to understand why it happens, and then you familiarize with the materials available in order to repair the concrete if you are facing this type of issues. So then you can have better knowledge in order to select the type of material according to the need in your hands. So epoxy, polyurethane sealers, we have also the penetrating sealers based on resin silicones, all of this. Good choice when you have the surface against strains in garage or driveways. So it depends on the circumstance. And then we know the main challenge is to avoid ingress of contaminants and excessive amount of water. So waterproof, it's one of the simple alternatives, depends on your project, right? We have here applications of waterproof. Why this is important? Because this is the only way to go to protect the concrete to to avoid its deterioration over time if you avoid the ingress of the chemicals and contaminants. So there are a variety of waterproof membranes based on polymers or bituminous here or PVC. So again, depends on what type of materials it's available in your countries, in your cities. So I also selected this application here. It's another video that I will leave with you because this is a real case study of concrete repair application. We have traditional brands around the globe. That this is one of them, but I truly believe this is going to be very important for you to have a look. You're going to receive all these, and yeah, I'm happy to If you have any doubts, any questions, we can discuss, or in other opportunities you can email me. It's up to you. Yeah, I know that's a brief technical webinar, but I really, as you can imagine, I really enjoy this opportunity to share the knowledge and my perceptions about concrete characteristics with you. And yeah, I hope you enjoyed it, and I wish you all the best. Thank you. Thank you very much for your company. I'm looking at chat box as well.
Yeah, I'm just about to post all of the questions, just to make it nice and easy.
Let me just go to the.
Make
I
myself
think
off screen as well.
yeah, I just look at the chat box. There's a questions about what is best, wet curing or the curing compound. The wet, first of all, we start with cost and benefit analysis. Wet curing definitely is the simple way to go, but you need to ensure the continuity of the curing. Otherwise, it's gonna happen what I mentioned. If you have cycles of wet and dry, it's not gonna be effective. So that's why in this case, the curing compound can ensure more continuity. But depends on if it's a simple project, you just need to evaluate the cost and benefit of it. But just keep in mind, continuity of curing is the way to go.
Sorry to interrupt, Dr. Anna. I
Oh,
believe
good.
there is a slide specific for Q&A, so could we just switch over to that one, if that's
Okay.
okay?
Yeah. Yeah, I have here.
I've just sent you the questions as well. I'll take myself off of thank you for the time.
And I think Nyasha just asked about disadvantages of epoxy coating. This is hard to say. I can tell you. Maybe one of the main challenges is about the cost of those type of materials. Yeah, it's straight away coming to my mind. I cannot say any significant disadvantage. All those alternatives is to ensure the protection of yeah, if you have the coatings, you can mitigate the issues in relation to the corrosion of the rebars. I have another one here, how to treat the salty coming out from concrete. This is if it comes from the original concrete mix, it's gonna be super challenging. But what can be done, for example, when you have the fluorescence or those, this whiting powder, when you clean up, you need to ensure a protective coat in order to, because all these reactions, they continues in the presence of water, oxygen, and if you just ensure that you have a denser coat, or we don't have impermeable concrete, right? That's why you need the coatings. The best alternative is when you do the repair, when you clean up, is just to ensure a proper cover, a denser or some kind of coating to avoid the ingress of moisture and the oxygen and water. I think those are the ones, Jasmine.
There is another one. I think it was is there a way to assess the strength reduction due to corrosion?
Yeah, it, the slides that I showed about the non-destructive techniques, we can understand the level of corrosion in our concrete. We can get the resistivity of concrete, but we need to establish a correlation. So because the corrosion, we are talking about what's happening with the steel bars, but it affects the concrete strength because you can see when the rebar, when there is an expansion of this, you have the cracks, right? Because you have some tensile stress concentration. So in order to ensure the strength of concrete in situ, you can do the rebound hammer test or ultrasonic test, or you can extract cores and establish this type of correlation.
Wonderful. I might just go through the next few slides if that's okay, unless you want to.
Yes, I can just, I think now it's about different opportunities at EIT and DCT.
Yes.
You can go for it, Jasmine.
Wonderful. So this webinar topic relates to our School of Civil Engineering and is particularly found in the following courses. So that's Professional Certificate of Competency in Repair of Concrete, Professional Certificate of Competency in Structural Design for Non-Structural Engineers, Professional Certificate of Competency in Building Information Modeling, which is BIM, at the Advanced Diploma of Civil and Structural Engineering, Material Testing, the Advanced Diploma of Civil and Structural Engineering, and then the online Bachelor of Science in Civil and Structural Engineering, which is amazing. So you'll be able to click on those links. That will take you directly to the course page once you get that, the slides. Wonderful. Thank you. And so you can see on this page the upcoming courses and the start dates in relation to them. A lot of them are starting next year, which is super cool. So you can prep yourself for that. And so I will post please feel free to
Yeah.
use the QR code or the certificate of attendance link that I've just posted in the chat. Um, this will be sent out to you in a few business days.
Another one.
This
I
is the
think some
Q&A
of
one,
the
but we've already
Q&A,
done this.
we
Any other
just wait.
questions at all?
I think it's just the last one from Mark about the concrete wall exposed to sulfuric acid. I think this one it's about the coatings, the epox, vinyl, or some acid resistance. There are specific products for this proposal. It's about the coat, and yeah, in combination with a denser concrete in order to resist against this. It's high, yeah, very aggressive type of uh, deterioration, this one.
And so on this page, you can see where to contact us. There's many different ways. Obviously, please ensure that you're contacting the right website per the, so if it's EIT or ECT, just make sure you're contacting the right ones. Um, okay, I think we've just had another question. Can you use treated water for concrete?
Treated water, sorry, what do you mean about treated water? And if you can just try to. Do you
From a
mean if
wastewater treatment
wait from the
plant.
way okay, okay. Uh, yeah, there are some lab tests that we can conduct in order to ensure the quality of water to produce concrete. It's becoming more and more common, this type of usage. But yeah, it's about, we use it to say, I think you all know this jargon. If it's a potable water, if you can drink your water, you can produce the concrete. But yeah, there are some limitations in terms of organic matter, in terms of the pH of water. Yeah, but it is also possible. But we need to have the chemical analysis of the water.
Wonderful. So I believe that brings us to the end of the webinar. Thank you so much, Dr. Anna. I really appreciate your time. I'll just end the recording now.
Thank you. Thank you all. Thank you, Jasmine, for your support always.